So dear friends, welcome to the next question of the electrochemistry that is in front of you. Discuss the determination of conductivity and cell constant. Now let we come to the answer. What is conductivity or the K? It has been pointed out that conductivity K is related to the resistance R or the conductance C. Means the conductivity is related to the resistance, that is inversely proportional, or the conductance C, as how K is equals to 1 by R into 1 by A cross sectional area, that is equal to C into L upon A. Here L is the distance of separation of two electrons. You can clearly see that is the L, the length between the two electrodes, that we can say over here L. What about the A? A is the cross sectional area of the two electrodes where we are taking the conductivity. Now the next thing is that the quantity is L by A is called as the cell constant. So length upon A cross sectional area is called as the, and this is the nothing but the cell constant. So the cell constant is expressed in the unit centimeter inverse. Now the last is that knowing the value of this all, the cell constant and the resistance of the solution, the conductivity can be easily calculated, as how the conductivity is equals to conductance into cell constant. So we can easily we can calculate. So that is your answer of the calculation of the conductivity. Now the determination of cell constant. The cell constant is generally not calculated from the values of L and A, that is the length and cross sectional area, because these are difficult to be measured for a given cell. So it is generally not possible to measure for a given cell, that is the L and A. So it is therefore more convenient to obtain its value by measuring the conductance of the standard solution whose conductivity is known. इसकी कंडक्टिविटी हमें मालूम है, तो उसे स्टैंडर्ड लेकर हम जनरली क्या करते हैं, कंडक्टिविटी या फिर सेल कांस्टेंट जो निकालते हैं. फॉर दिस पर्पज अ स्टैंडर्ड सोल्यूशन ऑफ KCl इज अंडर whose conductivity is known at different concentration and temperature. जिसकी अलग अलग टेम्परेचर और कॉन्सेंट्रेशन में हमें कंडक्टिविटी पता है, जैसे KCl सोल्यूशन, ऐसे को हम लेते हैं सेल कांस्टेंट निकालने के लिए. सो द फाइनली what will be the cell constant? That is the conductivity upon conductance. Now once the cell constant is known, the conductivity can be calculated from the measured conductance or resistance of the electrolytic solution. So cell constant is equals to, that is cell constant is equals to specific conductivity upon observed conductivity. So by knowing the specific conductivity and the observed conductivity, cell constant can be easily calculated. So in this way, there is the determination of cell constant. Now the next question is that how do specific conductance and equivalent conductance vary with the dilution? If we change the dilution, then if we do the dilution, then how the specific and equivalent conductance vary? So it can be again said as asked to us that what is the effect of dilution on equivalent conductance or the specific conductance. So these are the two ways by which the question can arise in your question paper. So answer is that in both the specific and equivalent conductance of a solution, it varies with the concentration. As the solution is diluted, more and more molecules of the solute dissociate. Hence the total number of ions in the solution increases. Therefore the equivalent conductance of the solution increases, because it depends on the total number of ions present in the solution. So as we do the dilution, number of ions changes, and hence the concentration will be increases on dilution. So what type of the conductance? Equivalent conductance increases. Why? Because it just depends on the total number of ions present in the solution. But at the same time, solution becomes dilute, the number of ions per meters cube decreases, and hence the specific conductance decreases, because it depends on the number of ions present per meters cube. Therefore this is the two difference. The equivalent conductance increases on dilution, whereas the specific conductance decreases on dilution. Now it has been mentioned that lambda V is equals to K into V. On dilution, the decrease in specific conductance is more than compensated by increase in the value of V. Hence, lambda V increases as mentioned above. Kohlrosh has shown that if equivalent conductance of various electrolytes be plotted against the root of C, that is concentration, the following curves are obtained. You can see clearly over here. So the graph has been plotted over here, the equivalent conductance versus the root C, that is the concentration, and you can find what happens to the specific conductance and the equivalent conductance. So for the revisionary purpose, keep in mind that what happened to the equivalent conductance? Equivalent conductance increases and specific conductance decreases. Why? Because the specific conductance is what? It depends on the number of ions present per meters cube, whereas equivalent conductance increases if the total number of dissociated ion increases in the solution. So that is nothing but the all about the equivalent conductance and the specific conductance. Now in the graph, we can see the curves for potassium chloride, sodium acetate and acetic acid are given in the figure in the previous slide. The first two are linear while the last one is non-linear. Means you can clearly observe from that the linearity of the curves. The electrolyte that gives a linear curve are called as the strong electrolyte, and the other are the weak electrolyte. For the latter, the value of lambda V are low at dilutions less than about n by 10, beyond which they rise very rapidly. It is seen from the figure given in the previous slide that the equivalent conductance in case of the strong electrolyte increases very slowly. This is due to the fact that strong electrolyte ionize to large extent at all concentration. However, in case of the weak electrolyte, equivalent conductance rises rapidly. This is because the weak electrolyte normally ionize to small extent and dilution makes an appreciable change in their degree of ionization. So that is the phenomena by which we are finding the curves of the strong and weak electrolyte, dear friends. Okay, so I think you have understood. If not, then please you can ask me doubt at group. Okay, dear friends. Now the next very important question: state and explain the Kohlrosh law. What is the Kohlrosh law? Kohlrosh obtained very interesting pattern between the values of lambda m infinity for different electrolytes. It was observed that the difference of lambda m infinity of different pairs of electrolytes having the common cation or a common anion, and it was almost same. For example, the difference between the molar conductance of potassium ion and sodium ion is 23.4 irrespective of the anion. That is very interesting fact observed by the Kohlrosh law. So you can see over here the lambda m infinity KCl 149.9, then lambda m infinity of NaCl is equals to 126.5, whereas over here the difference you can find that 23.4. In the next case, the lambda m infinity or lambda infinity m of KNO3 potassium nitrate is 145. Again the lambda infinity m sodium nitrate is 121.6 and difference 23.4. So that is the case. Means what? Irrespective of the anion, he has found that what? The difference of lambda infinity m of different pair of electrolytes having common cation and common anion was almost same. That is the interesting fact observed by the Kohlrosh. Similarly, the difference between the molar conductance of chloride and nitrate ions is 4.9 irrespective of the cation. In the second example, let's see. Lambda infinity m for potassium chloride is 149.9, whereas the lambda infinity m for the potassium nitrate is equals to 145.0, and you can clearly look towards here on the screen. The difference is 4.9. In the same way, lambda infinity m for sodium chloride is 126.5 and lambda infinity m for sodium nitrate is equals to 120 1.6 and difference 4.9. So you can clearly look and observe that in the first case potassium chloride, potassium nitrate. So what is common? The common is what in the first case? Let's see the potassium chlorine nitrate. So anion is different. In the same second case again the anion is different, but still in the first case there is the potassium and the second case sodium, so difference is the same. So that is the interesting phenomena has observed by, and the law is given by the Kohlrosh, and so hence it is called as the Kohlrosh law of the very interesting phenomena. So if you want to take the recap once again, let's see. In the first case the anions are common, chlorine to the potassium and sodium, so difference is 23.4. In the next second case again the cations are common, but only anions have changed, but still difference is common. Means what? Keeping the cation common, if you are changing the anion pair of in a pair of the compounds, so for the pair of cation if we change the anion till it is the constant, and the vice versa for the if we change the anion. So the conclusion can be drawn that each ion makes a definite contribution to the molar conductance at infinite dilution irrespective of the other ions, and this led him to the postulate, and that is the law known as Kohlrosh law of independent migration of ion. This law states that at definite dilution, when the dissociation is completed, each ion makes a definite contribution toward the molar conductance of the electrolyte irrespective of the nature of the other ion with which it is associated. For example, lambda m infinity of AB is equals to lambda n infinity of A, that is a cation, plus lambda m infinity for the anion or of the anion. Again the lambda m infinity for NaCl, that is the actual example, is equals to lambda m infinity for sodium cation plus lambda m infinity for the chloride or chlorine, that is the chloride cation. So that is the very interesting law, is called as the Kohlrosh law. So dear students, if you are having any doubt, any problem, please you can directly ask me in a WhatsApp group, or you can comment over here. So feel free to any time to ask the question to me. Thank you. Have a good day.